Okay guys, now with this equation let's try to calculate the net force here. Now look, this one, this cable here, I'm sure you can see it, this cable here, we're going to calculate his net force when interact with this one here and when it interacts with this one down here, right, the second cable. Now and we're going to do is this. First, the net force, let's call F1, is going to be to the force that is 1 exerting on 2 plus the force that is doing 1 exerting on 3, right? This is the first cable, this is the first cable, this is the second cable, the third cable. So we're going to look at the force that is interacting with 1 and 2 and then with 1 and 3. Okay, good. So let's calculate first F1 or 2. And if you remember the equation, it was what? Mu I1 I2 L divided by 2 pi A, right? Now look here, the A, how much is A? Let's put in the data. A is the distance between cable 1 and 2, which is 2 centimeters. It will be 0.02 meters. I1, let's call this one I1 due to the first cable, is 10 amperes. I2 is also 10 amperes. And L, the length, they say the length, well, let's assume that it is 1 meter. Oh, 50 centimeters, there it is, I forgot about that. It's 0.5 meter. Here's the length. So, substituting here, let's calculate then F1 due to cable 2. Right? So the force 1 due to cable 2. And if you remember the equation, if we go back one slide, oh, another slide, sorry, there is. The only thing we're sending L the other side. Let's go back. So this is going to be what? F12 is equal to 4 pi times 10 to the minus 7. Put it in its units, which is Newton ampere square, times the current, which is 10 ampere, times 10 ampere, times 0.5 meter, divided by 2 pi times the distance between cable 1 and 2, which is 0.02 meters. Okay, and if we do the calculation, we will get, and using your calculator, you will get something like 5.0 times 10 to the minus 4 newtons. Okay, now let's do the calculation with F13. Let's put it here somewhere, F13. So this is going to be what? Well, we have mu naught I1 I2 L divided by 2 pi. But now look here, this distance from here to here is not 2, it's actually 0.04, right? It's twice the distance, right? Because it's 0.2, oh sorry, 2 centimeters here and 2 centimeters here, it's 4. So if you do, and well, remember we have the same constant, which is 10 to the minus 7, the permeability. I'm not sure why this line is showing up there. Then we have 10 amperes and 10 amperes because it's the same, and all of them divided by 2 pi times 10 to the 0.04, and what we get after using the calculator, 2.5 times 10 to the minus 4. Now, before we give the numbers, they actually have different direction. Look, the first one with the second one, because the first cable with the second cable, because they have different directions, and this is the one who's going to tell you the direction, because we calculated the force with respect to the first wire. We know that this one is going up, is running away from it, F12. But then this one with the last one, because they go in the same direction. You can see its attraction is going down. But this is F13. But in terms of, you can see in terms of magnitude, F12 is bigger because the distance is shorter. You divide by a small number, you will get a bigger quantity. If you divide by a bigger number, you will get a smaller quantity. This one is going to be positive, but this one is going to be negative because of direction. F13 is going down. So when you put these two here and you add it up, it's going to be 5 times 10 to the minus 4 newtons minus, I'm sorry about that, 2.5 times 10 to the minus 4 newton. And the answer is going to be 2.5 times 10 to the minus 4 newtons. Why this one is subtracting? Because it's negative, the direction of the force is going down, while the other one, because of repulsion, is running away from it. Right? See? Oh, sorry about that. See? These two cables, the first and the second, has direct opposite direction occurring. So it will be repulsion. So it's running away from it. Now the first and the third one, they have the same direction, they will experience attraction. But because they're far away, the force is going to be slightly small, and that's why this one is negative. When you subtract, well, the net force is going to be positive. Now, if we do the problem with respect to the cable in the middle, what happened? F2 respect of F1 and F2 respect of F3, they are both at the same direction, at the same distance. They are opposite directions, so that means that the force here goes up and the force here goes down. They will cancel out. If you calculate, in other words, if you try to calculate F2, this one is going to be 0, because this one, F21, and this one, oh wait, actually it's not this one, sorry about that. Okay, I was saying that this one is the one who will tell the direction. This one against with this one, because they're in opposite direction, it will run away. This will be F21. Now this one against this one, because it goes in opposite direction, it will go up. That will be F23, and you can see in magnitude, because they're in the same there's a space, the sum out is going to be 0. It will be, one is going to be negative 5, the other one is going to be positive 5 times 10 to the 4 newtons. You add those two, is going to be 0. If you do the last one against the other two, the answer is going to be the same you did in the first one, but with a different sign, negative. Try that one. But now you do this one against this, repulsion goes down. This one against this, the same direction, attraction goes up, but it's too far away, so this force is going to be weak. 3 with 1 is going to be smaller than 3 with 2, right? And because it ended up being the bigger one going down, the answer for last one, which will be F3, which is going to be what? F31 plus F32, you will have what? F31, I said a moment ago, is going to be minus 2.5 times 10 to the minus 4 newtons. Is the same procedure we did somewhere else in one problem there a moment ago. And this is going to be, watch it, this is positive because it's going up. Sorry about that. The other one is going to be minus 5 times 10 to the minus 4 newtons, and it's negative because this one will be going down. And you will see that the answer is going to be minus 2.5 times 5 times 10 to the minus 4 newton. I'm sorry, the things are showing up they're not supposed to. Okay guys, I will try to do another problem. We'll discuss something else. I think it's amperes what is coming next. Okay, take care.